So like we worked on last week, the first thing I want to do is actually nail down where this is going to happen, and this is where that interval comes into play. So I know when I lay it out, I want to be down here in quadrant 3, because that's between pi and 3 pi halves. Tangent, we know, is y over x. So I'm looking at a triangle looks like this. Y is 4, x is 3. And it's kind of important to know that these are both negatives to get me to that point. And that also means I'm looking at a radius of 5 when I do the Pythagorean theorem. 3 squared plus 4 squared is equal to 5 squared. So I can go back now and say, all right, that means that sine of theta is going to equal negative 3/5. Cosine theta is going to equal negative 4/5. Tangent of theta is going to equal, oh, we already have that, 4/3. Which is the same as, I got those backwards. Four and 3. And then cosine we know is, or tangent we know is sine over cosine. We already had tangent coming in. So usually what gets students in trouble with this is the setup. And watching these signs. Because we tend to ignore that over the interval, or we forget what intervals those represent. So now when I talk about sine of 2 theta, according to my sheet here, if I look up the double angle identity, sine of 2 theta is 2 sine theta cosine theta. Sine theta cosine theta, which is going to be 2. Now sine is negative 4/5. Cosine is negative 3/5. And that whole thing simplifies out to, let's see, 2 times 4 is 8, times 3 is 24, 20/5, and it's positive. And as a safety check, you can look to make sure you still have a number between -1 and +1, because sine and cosine have to land in that range. So if you're getting something else, then you know you've got a mistake. Fire away.
The -3, -4 is because of the Austrian state calculus.
Right. Another way to think of it too is since we're in quadrant 3, that means that sine and that to get to this point down here, I have to go negative x and negative y. That's also going to give me sine and cosine are negative there. So that's another trick. But yeah, the all students take calculus is a nice reminder that the only things that are going to be positive, the only thing positive there is going to be the tangent. Everybody else should be negative. I'm going to do the cosine now. Cosine of 2 theta. Take your pick. They all will get you the same answer. I'm going to use the first one that's listed because, I don't know, why not? Sine squared theta. So that's going to be negative 4/5. Yeah, shoot.
I just keep confusing weird, like, plugging it into that equation type thing.
Okay.
Like, I never know.
Well, the key to this is cosine squared theta, gentlemen. Guys. Cosine squared theta, that's the same thing as cosine theta squared. I mean, we don't usually write it this way because of all the extra parentheses involved. But now I can see, well, I already know what cosine is. I found that up here. So I can write negative 3/5 and then square it. And then minus, and then do the same thing for sine. Negative 4/5 quantity squared. And that's going to give me 9/25 minus 16/25, which simplifies to a negative 5/25. 7. And that does not reduce.
Is the sine squared or is it just? Yeah.
Yeah. I'm taking the sine of theta, which is negative 4/5, and squaring it. That's what sine squared theta really means all by itself. And again, my safety check, I want to be sure that I'm not accidentally shifting outside of, shift that over a bit. make sure I'm not shifting out of that range of accepted values down here for cosine. Tangent's the one that you don't have that safety net. Tangent will yield you numbers anywhere from negative infinity to positive infinity. Shoot.
How do you know this is a range? -7/25. Did you just like convert that to radians or something?
I know it's in the range because cosine will always give me numbers that range from +1 to -1.
Oh.
So as long as I'm getting something that's a fraction that's less than 1, at least I'm in the right ballpark. I haven't completely jumped the rails.
What about sine?
Same deal. Because sine's the same graph, except that it starts at 0 and goes up.
So as long as it's not like above 1.
Yeah.
Below -1.
I mean, it's not a great safety net, but it's one more thing you can add to your arsenal of things to be sure I didn't screw this up too badly.
So if it's like 4.
You screwed it up badly.
Yeah.
Yeah. 4 is right up. So is 5. And then we can go into tangent. And again, this is one where there's a limited number of, there's only one equation for tangent 2 theta. So 2 tangent theta over 1 minus tangent squared theta. It's ugly, but it's not horrific. So 2 times 4/3 all over 1 minus 4/3 squared. So I have 8/3 and then 1 minus 16. Pen got ahead of the brain. 16/9. Now it's a fraction headache, really. I have 8/3 over a negative 5/9. No, 7/9. Which, clean that mess up. That's not going to clean up all that pretty, is it?
No, it's -6/7.
Negative 6/7?
I think so. Oh wait, no. When I rewrote my fraction, I
Yeah.
renumbered it.
Well, here, let's just divide fractions and multiply by reciprocals, right? So negative, and then we'll talk about another safety net you've got. Oops, 9/7. So 8/3 times 9/7.
It's a 24.
These cancel, leaving me 3.
Why is it not -9/7?
Because, oh, I put my negative down here.
Yeah, but like when you multiplied,
Yeah, you can, if you really like, you put
No, it's fine.
your negative over there. Now, speaking of safety nets, let's go back for a second. If I didn't want to do all that work, I know what sine is. Sine of 2 theta is 24/25.
Or you just divide it.
Cosine of 2 theta is -7/25. So if you do 24/25 over -7/25 and reduce, you're going to end up at -24/7. So you have another tool in your box there. Because remember, tangent, let's see, where's my pen? There's my pen. Tangent is sine over cosine. So if I had done sine 24/25 over cosine -7/25, 25 cancels 25, leaves me -24/7. A little bit faster, if I remember that rule. It's also a nice safety check. You know, make sure everybody's jiving. It also gives me a hint that my sine and cosine are right. So if I do the tangent out longhand and then I do the short cosine and cosine, everybody converges, it means I'm nailing it. Shoot.
Will we have calculator on this test?
Yes.
So we can just plug into a calculator.
You want to be real careful though, because unless you're really savvy with that calculator, it might be tricky to get the decimal that will kick out back to a nice neat fraction like 24/7.
Math fraction.
Or you can just check it and see if it's the same decimal.
Plus I gotta grade your work, so. Yes?
What are the limits for tangent?
Tangent has no limits, sadly. Because remember with tangent, and this little mini graph I've got tucked here into the center of the page. Tangent does one of, yeah, it goes through the origin. It does one of these jobs.
Oh yeah.
So there is no, oh gosh, I got this really big number. Yeah, that happens. Oh, I got 0. Yeah, that happens. I mean, there's not a lot that makes tangent easy, sadly.